All right, guys. Obviously, tomorrow we have our first quiz of Unit 2. So I just wanted to go over the parallel review with you guys, make sure everything's all good to go, give you an extra opportunity to hear me go through everything one more time. This will be on our Google Classroom, along with the answer key all worked out as well. So you have your choices. You can go ahead, you can listen to this, or you can just look at the paper copy and follow along that way. All right, so obviously I'm starting with number 5 here. Our 3 stars you can find on the paper copy. I'm just trying to save some time and get going on the actual math pieces here. So to begin with here, we have 2 functions that are given to us. Our f of x equals negative 4x minus 3, and g of x equals 3x minus 7. So we're asked, what is the value of f of negative 7 divided by g of 3? All right, this requires us to do a couple steps. First, we need to find f of negative 7. Then we need to go ahead, find g of 3. Then we put them together with the division. So let's start with f of negative 7. Okay, again, all we are doing with f of negative 7 and actually g of 3, all it is a substitution problem, guys. We're going to go ahead and use a calculator if you need to. Just anywhere you see x in your f function, in this case, we are going to be plugging in negative 7. So I have negative 4 times negative 7 minus 3. I go ahead, I push this button on the calculator, or I can do this in my head. Negative 4 times negative 7 is 28. 28 minus 3 is 25. Okay, so there's our f of negative 7. We have to find our g of 3 as well. G of 3. Again, anywhere you see x in the g function, go ahead and plug in 3. So I have 3 times 3 minus 7. Okay, 3 times 3 is 9. 9 minus 7 is 2. So there's my g of 3. And of course, we have to take both of those, combine them together with the division. So f of negative 7 was 25. G of 3 was 2. We do 25 divided by 2 to give us our final answer for this question, which is 12.5. Okay. For the next one, for number 6, okay, we are talking about if a relation is a function or not. All right. There's a hint on there to draw a mapping diagram. Okay. So if you guys remember our mapping diagrams, we talk about our domain, we talk about our range. Our domain is a list of all x coordinates. Our range is a list of all y coordinates, okay? So for my domain here, draw a little D for domain, okay? I write out my x coordinates. I have 3, negative 2, 0, and negative 5. Notice negative 2 shows up twice, so I'm not going to write it twice. I only write it one time. Okay, my range or my y coordinates, here's my r, okay, I have 4, 6, 7, 3, and I forgot 9. I didn't do the first one. It's okay, doesn't matter the order, because we're going to draw arrows between the two anyway. So I go ahead and combine what actually goes together here. So in this case, 3 goes with 9, so I'm going to draw my arrow from the 3 in the domain to 9 in the range. Negative 2 goes to 4, as well as 7. Okay, 0 goes to 6. Okay, and negative 5 goes to 3. All right, now this question is asking, is this a function or not? Okay, how we can tell is if that domain, if any numbers in the domain have 2 arrows coming out of it, it means it's going to 2 members of the range. That is going to be false. We do not have a function in that scenario. In this case, we have negative 2 here is going to 2 different numbers. It is going to 4, and it's going to 7. We don't like that. This is not a function. So for our question's purposes, this would be considered false. Okay. Here we are trying to find domain and range. Okay, so this is our soft bracket versus hard bracket question. So our first thing we're going to go through here, we're going to find our domain. Okay, our domain for this first function, all right, is a list of all of our x's. Okay, so what we have to ask ourselves is there a smallest x value? Meaning, on my graph, can I point to a spot that is the smallest for the x's? Well, in this case, because I have my function here has an arrow at the end, okay? This function is going to continuously get wider. Therefore, I do not have a smallest x value. I am going to use negative infinity to represent this, okay? I ask myself the same question now, but instead, for the largest value. What is the largest value for x? Well, I'm looking at this. Once again, I have an arrow out over here at the top of my graph. It is extending out towards the right. Therefore, I do not have a biggest x value, and I need to use infinity to represent that. Okay? Now, every time we've talked about this, anytime we use infinity, we always use our soft brackets, otherwise known as parentheses. Okay? Going through the range, we now ask the exact same questions we did for the x's, for our domain, but now we do it for the y's. So, first things first, is there a smallest y? The answer is yes, there is. It is right here at 0. We can clearly see that is the smallest point on this graph in terms of y. So my smallest y is 0. I then go ahead and ask myself, is there a highest point? In this case, no. I've got my arrows at the top, and that would indicate that it goes on forever in an upward direction. Therefore, we do not have a biggest y, and we need to use infinity. Okay? Now, with the 0, we look at the graph. The graph runs nice and smooth through that 0. Okay? If it is a closed point for us, we would use a hard bracket, also known as just a bracket for us. Okay? And then anytime we use infinity, just as we just said on the last problem, it is a parenthesis. Okay? Doing the next question there, number 8. All right? We'll do this one a little bit faster. Okay, so our domain, if we look at that, again, we have arrows on both sides of this. Okay, we have arrows pointing off forever in the leftward direction, arrow pointing off in the right direction forever as well. That means we do not have a smallest x. We also don't have a biggest x. So I am going to say, for my domain, my smallest was going to be negative infinity, biggest is going to be positive infinity, and again, just like on the last problem, we go ahead and always use our soft brackets, also known as parentheses, around infinities. I now go through the same thing with range. Okay? Now, range again, arrows pointing off in both directions forever. Therefore, we need to use our negative infinity once again, and our positive infinity. Okay? And always around infinity, we use parentheses. Okay? Numbers 9 and 10 are asking you if 7 and 8 respectively are functions. How we go about doing this is we go ahead and, alright, so to go about doing that, to go about figuring out if these are functions or not, we use what is called the vertical line test. Okay, remember, for a function to be considered a function, we do have to pass the vertical line test in every spot. So what the vertical line test is we are going to go ahead and we're going to draw a vertical line at any random point on our graph. Okay? If the vertical line only hits one time, one point on our graph, then we say it is a function. If it hits more than one, it is not a function. Okay? So like I said though, it has to pass everywhere. So I should be able to pick another spot, like right here for example, and it should only still hit once. That is the case. If I pick a different spot, like right here, it only hits once. So therefore, number 7 is a function, which gives us number 9 to be true. Going on to number 8. Once again, I go ahead, I draw my vertical lines for the vertical line test. And as you can see, as we go through, it only hits one point at a time. Therefore, number 8 is also a function, making number 10 true. Number 11, we are asking about slope. Okay, slope, if you are ever lost on where you can find your information for slope, first of all, you guys know it is on the wall. It's that big blue rectangle above the Getting Started poster, okay? Also, you can flip back to the front of the quiz. You should have already wrote down the slope formula for one of your 3 stars. So, just to remind you, the slope formula is m is equal to y2 minus y1 over x2 minus x1. I go ahead and I do my substitution really quickly. Y2 is 7, y1 is 0, x2 is 4, x1 is 8. Okay, 7 minus 0 is 7, 4 minus 8 is negative 4. I can't simplify that at all, so that is my slope. That is my answer. Okay, number 12. Write an equation in slope-intercept form for the line with a slope of 5/2 and y-intercept of 0.8. Okay, so slope-intercept form, most of you guys will know and remember without having to look back at the front, but you're more than welcome to. Y equals mx plus b. Okay, in this case, this is a very nice problem for us. It gives us our slope, it gives us our y-intercept. All we have to do is substitute the values in. So when I do that, I will have y equals, all right, my slope is 5/2. Okay, my y-intercept is at 8. So nice, easy problem for you. Number 12, just substitute the values and they give. Okay, number 13. Okay, 13, guys, we have to, again, write in slope-intercept, so that is y equals mx plus b. However, it does not give us both pieces of information we need. It gives us a slope and it gives us a point. That point is not the y-intercept, so we are going to have to use point-slope form. Point-slope form is y minus y1 is equal to m times x minus x1. Okay? All we have to do now is substitute the values it gives us. All right? So, y1 is 9. Okay? The slope is 3/2. And x1 is 4. All right? I go ahead. I need to clean this up now. I'm going to distribute the 3 halves, the 3/2. Okay? This side is nice, does not change. Okay? Over here, 3/2 times x. Nice and simple, 3/2x. Okay? And 3/2 times negative 4 is negative 6. All right? Get y by itself, simply add 9. And we have y is equal to 3/2x plus 3. Okay? All right, guys, so this is going to be part 1 of this video. There will be a part 2 as well. Part 1 covered 5 through 13. Part 2 will cover the rest. Okay?